All right, ladies and gentlemen, let's do probability, chapter 10. So we are going to learn how to count, which is excellent. When you're doing a sample space, we're going to talk some probability language, even though right now we're just learning like how to count up the ways things can happen. But a sample space is going to be like all the possible outcomes. I don't know why this is wiggling around so much. Okay, stop. There we go. So when you list all the possible outcomes, so like if you're going to toss a coin 2 times, you could get tails and then tails, tails and then heads, heads and then tails, or heads and then heads again. So those are your outcomes. Sample space is like showing them, listing them out. Like this is the possible outcomes for what I'm doing. We have to learn how to count them up without writing them all out every time because that can take forever. Another way to do this, by the way, is a tree diagram. So like in your first round, you would either get tails or you would get heads. And then here you could get tails or heads the second time, same thing here. And then in a tree diagram, to get the same list of outcomes, you kind of follow the branches. So there's tails and tails, tails then heads, heads then tails, heads and heads again. So it's the same outcomes, the same sample space. It's just written out a little bit differently. So kind of whatever makes the most sense to you. So what we're going to be talking about first is like how many ways can this happen? How many ways can that happen? And so obviously one way is to write out all the options like the tree diagram or the list that we just talked about and then count. So like here there's 1, 2, 3, 4 possible outcomes. Or if I'm using my tree, there's 1, 2, 3, 4 possible outcomes. That's not always the most efficient. What we're going to be looking at today is fundamental counting principle, which sometimes works and sometimes doesn't. And then we have 2 specific scenarios called permutations and combinations that we use to count. And we're going to do that in 10-2. So listing the sample space for tossing 1 coin. Okay, well, 1 coin, I'm going to get tails or heads. That's it. So I have 2 possible outcomes. 2 coins we did up above, and so we ended up with 4 possible outcomes. With 3 coins, I could get tails, 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 and then what I do is I just do the exact opposite right next to it. Heads, heads, heads. I could get tails, tails, heads last, and then I just do the exact opposite here. I could get one that is heads in the middle and then do the exact opposite here. Or the first one could be heads and then do the exact opposite here. And that is all of my outcomes, which would take a while if you weren't a math teacher and didn't do it every single year. But you can see from this that I had 8 possible outcomes. Okay. 1 die means I could get a 1, a 2, a 3, a 4, a 5, or a 6. That is my sample space. I have 6 what we call possible outcomes. Here I had 8, 4, and 2. 2 dice, if I had to write them out, that would take me like absolutely forever. So what I'm going to do is think, okay, well, I have 6 outcomes in my first die. And then the second time I have 6 more outcomes. And so I would end up with 36 possible outcomes. That is going to tie into what we call the fundamental counting principle from up here. And what that allows us to do is take a shortcut without listing all the possibilities. Because like here I would have been like 2 dice. Well, I could get a 1 and then a 2. Oh, excuse me, I could have gotten a 1 and then a 1. 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6. But then I would also have to go, or I could get a 2 and a 1 and a 2 and a 2 and a 2 and a 3 and so on. And I would have to do that for all the possibilities of getting 1, 2, 3, 4, 5, 6 on the first roll and then all the possibilities. So what I would end up with here, if you can see it, is this would have 6 options across, 6 options down. So almost like finding the area, 6 by 6 would end up making those 36 possible outcomes. So in the counting principle, you are just figuring out like how many different options you have. And so the fundamental counting principle is going to take like however many decisions you have or however many trials you have. And then, so this is going to be how many times are you tossing the coin? How many choices are you making for something? I can't write. And then here you put the number of outcomes in each of those decisions or trials or spaces. And then the product of those is going to be your answer. So what does that mean? Back here, 1 coin, 2 options, my total is 2. 2 coins, but in each toss, this is like toss number 1, and this is my coin toss number 2. I have 2 options here, 2 options here, so 4 options altogether. 3 coins, again, toss 1, I have heads or tails, heads or tails, heads or tails, so 2 options 3 times over makes the same 8 outcomes that I calculated by doing the problem. 1 die, I literally am tossing it 1 time, there's 6 options, 6 outcomes. Here, if I have 2 rolls of the dice, I on the first one have 6 different numbers I could get, then 6 different numbers here, which makes for 36 possible outcomes. Okay, so let's go to this one. A sporting goods store offers 3 types of snowboards: mountain, freestyle, carving, I don't even know what that means. 2 types of boots, soft and hybrid. List the different packages the store offers for snowboarding. Well, I like to figure out how many options there are going to be. If I have 3 different kinds of snowboards and then I have 2 different types of boots, I'm going to have 6 possible outcomes. So the way to write those out, we'll call these all mountain, freestyle, and carving. And then we have soft or hybrid for boots. So like the easy way to do this is to say, well, I could have all mountain with soft, all mountain with hybrid. I could have freestyle with soft, freestyle with hybrid. I could get carving with soft or carving with hybrid. And that's my 1, 2, 3, 4, 5, 6 outcomes. But listing them and thinking of all the possibilities is tricky. So I sometimes like to start by thinking I have 3 of this kind, 2 of this kind, so I should have 1, 2, 3, 4, 5, 6 outcomes, and then I kind of get a better chance of if I'm done. All right, so let's test this out a little bit. You are at a Mexican restaurant. You order a taco plate. You choose hard or soft taco shell. So like my first decision is going to be shell type, and I have 2 options. You choose 1 meat, beef, chicken, or fish. Okay, so for your meat choices, you have 3 options. You choose either no cheese, American cheese, or Colby Jack cheese. So in my little cheese choice, I have 3 options. I don't have to get any. I can get American or Colby Jack. Then it says you choose 1 extra ingredient. So then I have a choice of an extra thing, and there's lettuce, tomatoes, sour cream, or guacamole. So that's 1, 2, 3, 4 different options. And then finally, you choose a side of either refried beans or Spanish rice. So that's 2 options. So when it asks how many different types, how many ways can that happen, I'm literally taking the 2 times 3 times 3 times 4 times 2, and there are 144 ways, so I'm really super happy I don't have to write out all of my options. But that is the fundamental counting principle, is you make like a space for each decision and then put in there how many choices you have for each one. You need to make a 6-digit passcode. Okay, this is me making passcodes that I can't remember. How many passcodes can you make if you can repeat digits? First of all, let's talk about digits. Digits are numbers, but one singular number. So 0 is a digit, and then 1, 2, 3, 4, 3, 4, 5, 6, 7, 8, 9. Now, that actually means there are 10 of them because we're counting 0, including 0. So if I have a 1, 2, 3, 4, 5, 6-digit code, and I can repeat digits, I actually have 10 choices for a digit in each of these spots. And instead of doing 10 times 10 times 10, I can just do 10 to the 6th power, which is going to turn out to be 1 million. Or you can multiply 10 by itself 6 times. Now, why is part B different? How many different codes can you make if you cannot repeat? All right, well, I still have to choose 1, 2, 3, 4, 5, 6 options. In the first spot, I can pick any number I want. But since I can't repeat, like let's pretend I picked 5. Now I don't have the option to pick 5, so now I just have 9 options. And then, whatever I picked is no longer an option. So now I only have 8, then 7, then 6, and then 5 options. So I'm going down in how many options I have because I can't repeat numbers. So that's significantly less because I've dropped from 1,000,000 options to 151,200. Now, this is where it gets tricky. You have to look at the specific situation. What if the code has to start with either a capital letter or a lowercase letter? You cannot repeat the digits. Okay, so we have 1, 2, 3, 4, 5, 6. So we're going to start with a capital or lowercase letter. Well, in the alphabet, there are 26 letters. But if you can use 26 of them capital or 26 of them lowercase, that's 52 options for this first spot. And then it says you cannot repeat the digits. So I'm assuming that means the rest of these are numbers. I would have 10 to choose from here, but then just 9, 8, 7, and 6. So then I just multiply my options together. So I'm on my calculator taking 52 times 10 times 9 times 8 times 7 times 6. And that's giving me this many options because that's more than 1,000,000 since I could start with 52 choices instead of just having the 10 digits to choose from because there are more letters than digits. All right, let's keep practicing. These can make your mind bend, but you just have to ask yourself, like, how many options do I have for each space? So the standard configuration for a Minnesota license plate is 3 digits, 3 letters. Okay, keeping in mind there's originally 10 digits and there are 26 letters in the alphabet. How many different license plates are possible if letters and digits can be repeated? So I have 3 digits followed by 3 letters. So here, if I can repeat, I can use 10, I have 10 options each time. And if I can repeat letters, I have 26 options each time. And so you can multiply that all out, or you can type it into your calculator as 10 to the third power times 26 to the third power, because you're multiplying 10 times itself 3 times, and then multiplying that by 26 times itself 3 times. So I have a lot of options. I got this big fat number. Because as soon as you have the option of putting letters in there, you just have way more choices. How many license plates are possible if you cannot repeat? Okay, so now I have 3 digits, 3 letters. This is going to go 10, but then 9 and 8 because once I've used up a number, I don't have that choice anymore. Here I have 26 choices, but now that I picked a letter, I only have 25 other letters I can use, and now I only have 24 other letters I can use. And so I'll multiply those numbers together. I'm just busy being here on my calculator, and I'm ending up with fewer options, but still a boatload. All right. So that's our fundamental counting principle, is just kind of knowing how to say, hey, how many choices do I have in each of these spots? And then multiplying them all together. Hope that helps. Bye, guys.